All right, welcome everybody for our afternoon session. Glad to have you here. And anyone who would like to join us, come on in. We're about to do a live AWS demo. Please welcome to the stage Sunil Malia.
Thank you. Thanks guys for joining. So today I'll describe how you can train your models. Once you've trained the models, deploy it on serverless and create an endpoint. So if you look at the traditional pipeline that you have with machine learning, right? You go from data, you pre-process your data, and then when you create your models. But once that's done, you're looking at, OK, how do I get a prediction API and deploy it? So Amazon SageMaker, which was announced today, makes this very easy, where you modular from a training aspect. You can train your scale your cluster, train your models. It also has an independent deployment component as well. But as you might have seen with serverless, where it's often beneficial, where you might not have, you might just want to be testing or iterating really quickly on certain endpoints, but also you don't want a dedicated infrastructure. You want that heavy lifting to be done by AWS. So from a cost perspective, and also just to be able to spin up an endpoint seamlessly, I've created a repo with MXNet, all the necessary bundles. But not just that, I created a Jupyter notebook, which integrates with SAM, which is serverless application model, to be able to deploy the Lambda function and API gateway pretty easily. So let's look a little bit about the code. So it looks similar to any Lambda function, where you have the Lambda handler, you get the URL. In this case, I'm calling a predict function that does the job. Now, what's happening is most of the machine learning models, let's say you tend to develop, may be larger than the Lambda deployment. So the Lambda currently has a limit of 15 megs zip limit, so it's hard to package everything. So what I did was, from an architecture point of view, download the model and keep it in memory so that we can reuse. So the way we can do this is anything outside the Lambda context handler that we saw is kind of treated as a global variable, so or a global static variable. So this is not loaded or initialized every time you have a request. It is almost cached in memory. So if we download the model and keep the object outside of the context handler, it is persisted across requests, so we don't pay the penalty of downloading and initializing the model every time. So that way, you actually get the benefit of, you only pay the penalty once, but once the Lambda function is being warmed up, you get to use it. So just quickly looking at the code, here I'm using MXNet. So Apache MXNet, I've provided all the necessary libraries to be running this. So the model files, so we specify the model files. One is a binary model file. The other one's a JSON that describes the model structure. And then I have a function here where we do, OK, we load the model. And this model in particular we're using is a geo lookup or geo prediction model. What this does is, given an image, it's going to tell you where the image was taken. It doesn't use like the EXIF data. It's actually trained on a bunch of images that were taken for a particular location. And so this was built using the Multimedia Commons data set, which had like the geo coordinates, and it was trained using that. So roughly around 500,000 images that the model was trained on. So the model outputs is, given an image, it gives you the latitude and the longitude. And what I've done is I use a GeoPy library here to do a reverse lookup. So it's the GeoPy library. sorry, I'm trying to look. It does a reverse lookup. So given a lat long, it gives you the city and the address of where it thinks the image is. So once we have done here, what we can do is we write the file. So it's easy to edit the Lambda code in Jupyter Notebook. You can execute the cell. It creates a Lambda function file. And the next thing is we can actually, we need to zip the file. So all that is provided here. And here's a handy function to just update the code just in case. So serverless application model uses two files. So it uses two YAML files, a template YAML, the Swagger file to define the prediction, define the API gateway endpoints. So all you need to do is substitute your account ID, and the helper code here writes that for you. And then it uploads that to your S3 bucket and your Lambda function zip file as well. Then the next thing is you use the AWS CloudFormation template to create the CloudFormation stack. And once you package, you first package it, and then you create the actual file. And once you have done that, it actually gives you an API endpoint, and all that is automated. So you literally need to just substitute with your account ID, and the rest of the deployment is automated. So let's take a look at how the model. I've already, in the interest of time, I already deployed the model. So let's actually look at this image. Any guesses as to where this is? The Statue of Liberty in New York, right? So let's actually execute and see. Oh yeah, sorry. Let me execute again. That says it's Manhattan Community Board number 1, so Statue of Liberty, Liberty Island. So it has actually guessed the image correctly. So maybe we'll have more fun, right? Like, how many other Statue of Liberties or replicas do you think there are? There's one right here, right? In Vegas. So let's actually, so I have an image here. Sorry, that's not the one. We can try that. Like, we can try the Eiffel Tower. So this is the Eiffel Tower in Paris. So it does detect it in Paris. I just wanted to give it a little fun one, right? Like, so this is actually the Statue of Liberty. If you didn't know, this is actually Statue of Liberty in Paris. That's the other one that the French didn't give the Americans. So let's see if it can detect. So it was able to detect that it was actually France. So it's a pretty good model. But as you can, more importantly, as you see, it was so easy to deploy a model, and the response times have been pretty fast. When you think about the model has to download the image and go through the process. And the model here is about 400 megs. So it's a pretty heavy model. So what I'd done was actually benchmark the model to see, hey, what is the latency that we see when we do something as heavy as that? And we get about an average latency of 1.2 seconds from San Francisco to West 2, that is Oregon. But also, here's kind of a benchmark all over the world. As you can see, everything under about a second and a half. So it's near real time. You can achieve near real time predictions for really heavy models using Apache MXNet on Lambda, which makes it a pretty viable option for you to use this to deploy and build your inference on Lambda. So it's not just restricted to, so the code is actually available. If you go to AWS Labs/MXNet Lambda, the code is available here and open sourced. But there's also, so Keras, which is another very popular deep learning framework. I've made that available as well in the GitHub repo. There's a Keras package where instead of using MXNet, you can use Keras with the TensorFlow backend and deploy it in a similar fashion to what we saw with MXNet. So I just wanted to show one other image, right? Like we looked at all the popular ones. So wanted to kind of get this image, which is this is actually Svalbard, which is one of the remotest inhabited regions in Norway. So let's actually try and see if we can detect that. I was able to get it. Was in Svalbard, Norway. So that's what I had in store today for a demo. So with the benchmarks that we've seen, it's a pretty viable option to be using Lambda. And you can expect more enhancements in terms of, I'm going to contribute like an A/B testing module and so on, where you can have multiple models and track which one's doing better. So thanks for listening in, and I'll be here for questions after this. Thank you.
Thank you, Sunil.